Hello students, I am Tara Sawant from Empower Education, and today we are going to start with an interesting chapter in physics, light reflection. Now let's talk about the uses of concave and convex mirrors. Now you must be using concave and convex mirrors in your day-to-day life. Now there are certain places where concave mirrors has a large amount of application. For example, if you have ever visited a dentist, the dentist sees your teeth with the help of a concave mirror. Now, why is that so? Because a concave mirror can magnify an object or magnify and give a magnified image. So the teeth appears to be smaller, but if you view it with the help of a concave mirror, an enlarged image of the teeth has been seen. Now there are many more applications also of concave mirrors. Now headlights of cars, they are made up of concave mirrors. Satellite dishes, these are also made up of concave mirrors. Even shaving mirrors are also made up of concave mirrors. Now talking about applications of convex mirrors. Now convex mirrors are used inside buildings. They are used as vehicle mirrors. They are used for security purposes. These mirrors are used because they give a wide area of the field that we are observing. Now, you must have observed in the rear mirrors which are used in vehicles. Now, you can see a wider view of whatever is behind you. So, these are certain applications of concave mirrors and convex mirrors. Okay, so we had an entire discussion. Now let's have a look at certain questions. Now the first question is, define the principal focus of a concave mirror. Now as we have already discussed that the principal focus of a concave mirror is the point where all the rays, the reflected rays meet at a point. So when the rays are reflected from the reflecting surface, they tend to intersect at a point, and that point is the principal focus of a concave mirror. Let's move to the next question. The radius of curvature of a spherical mirror is 20 centimeters. So what is its focal length? Now, we know that the radius of curvature is equal to twice the focal length. So if the radius of curvature is 20 centimeter, that will be equal to 20 is equal to 2 into f, and then divide 20 by 2, which gives me the focal length is equal to 10 centimeters. Now let's move to the next question. Name a mirror that can give an erect and enlarged image of an object. Now through all these discussions, the formation of image by the concave mirror and the convex mirrors, you must have known by now that how the image is formed by these two mirrors. So please try it whether you can answer this question. The answer of this question is, it is a convex mirror. A convex mirror can give an erect and enlarged image of an object. Let's move to our fourth question. Now, why do we prefer convex mirror as rear view mirrors in vehicles? Now you see that convex mirror gives a wider field or wider view of a field. So since it gives a wider view of the field, it is good that we use convex mirrors in vehicles, because then the objects behind us can be seen very clearly. So this is the reason why we use convex mirrors as rear view mirrors in vehicles. Now let's move to our next concept, that is mirror formula and magnification. Now before talking about the mirror formula and the magnification, let's have a look at the diagram that is shown here. Now you can see in this diagram, we have a mirror, and in the mirror we have the principal axis. Now look at the principal axis. You can consider that the principal axis is the x-axis, where the pole of the mirror divides the x-axis into two parts, that is the negative axis and the positive axis. So towards the left, we have the negative axis, and towards the right, we have the positive axis. So you see here that when we talk about the position of the object and the position of the image formed in these mirrors, we can explain the position in terms of the x-axis, whether it is placed in the positive x-axis or it is placed in the negative x-axis. So before talking about that, we should know certain terms when we talk about the mirror formula. Now in mirror formula, the distance between the image and the pole is denoted by V. The distance between the object and the pole is denoted by U. And the distance between the focal point and the pole is denoted by F. So we got the denotions of the object, the image and the focal point. This gives rise to a mirror formula. Now here it is clearly shown to you the mirror formula, which is 1 upon V plus 1 upon U is equal to 1 upon F. Now this formula, you should remember it because it can be used to solve various numericals based on the position of the object and the formation of the image. Now let's talk about magnification. Now magnification produced by a spherical mirror is the extent by which an image is magnified with respect to an object. So if you write it in mathematical terms, the magnification can be written as height of the image upon the height of the object. So magnification is denoted by the letter M, and M is equal to h dash upon h, where h dash is the height of the image and h is the height of the object. Now this magnification can also be written in terms of distance of the image and distance of the object. If we write it in mathematical forms, it can be written as M is equal to minus V upon U. So again, we have the questionnaire round. So the first question here is, find the focal length of a convex mirror whose radius of curvature is 32 centimeter. Now you see the radius of curvature is given to us, which is 32 centimeter. And by now you should know how the radius of curvature is related to the focal length. Now radius of curvature is equal to 2 times the focal length. So if you're given the radius of curvature, that is 32 centimeters, divide 32 centimeter by 2, which gives you focal length is equal to 16 centimeter. And that is your first answer. Now let's move to our next question. What is the magnification produced when the height of the image is 30 centimeters and the height of the object is 15 centimeters? Now we know here that magnification is the ratio of height of the image upon height of the object. If the height of the image is 30 centimeters and height of the object is 15 centimeter, then it is 30 divided by 50, which gives us the magnification is equal to 2. So students, with this we have completed reflection. Let's have a quick recap of what we have learned today. Uses of concave and convex mirrors. We learned about the mirror formula and magnification, where mirror formula is 1 upon F is equal to 1 upon V plus 1 upon U. Magnification, which is the ratio of height of the image upon the height of the object, that is equal to minus V upon U, which is the distance of the image upon the distance of the object. So I hope you like this lecture on reflection, and in the next coming lecture, we will do more about refraction. And don't forget to subscribe to our YouTube channel, Empower Tutorials, And for more upcoming videos, stay tuned to our channel. Thank you.